Hello, viewers. Welcome to Media One YouTube channel. Today, we want to come to you with another set of questions on SED. I'm Samuel Watson College with my brother in US, Samuel Abrebe. Let's look at our first question. Yes, simplify 3 root 75 minus root 12 plus root 108. Yes, this is arithmetic with numbers, but it's technical because you are going to use properties of SED to add and then subtract and multiply. Okay, now to solve this question, let's begin by simplifying the numbers under the square root. The SED, we need to break them down. So looking at the numbers, there's no common SED. There's no common SED in which we can use to add or subtract. Or that is one of the properties. Before you can add or subtract, the SED must be the same. I mean, the number under the square root must be the same. Now, to break the number, you make sure you break it into a perfect square and another number. Sometimes it's difficult to get a perfect square, but you try. If you are not getting, you don't worry. You break it into simple numbers, and at the end of the day, you arrive at your answer. But then when you get the perfect square, it will help you to simplify it faster. So when you talk of perfect square, when you take a square root of a number and you get a whole number, for example, root 4, which is square root of root 4 is 2, root 9 is 3, root 16 is 4. This is what we are talking about, perfect square. So the numbers under the square root, you try to break it into one of these. As I said, if you are not getting the perfect square, you don't worry. You just take any two numbers and then you break it down. So let's start. Equal to, this is equal to 3 times, yes, 75, we can write it as 3 times 25. Good. Minus, so the perfect squared is 25. 12, for 12, we can write it, break it down as 3 times 4, plus 108, with 108, we can write it as 3 times 36. So looking at them, you see, the first term we have 25, the second term we have 4, and then the third term we have 36. So let's use the properties of SED. So we are going to have 3 times, with this you can write it as square root of 3 times square root of 25 minus square root of 3 times square root of 4 plus square root of 3 times square root of 36. In case you have forgotten, please go back to properties of SED and you get everything. The next step, equal to 3 times root 3. Root 25 will give you, because it is a perfect, will give you 5 times 5. Minus root 3 times square root of 4 will give you 2, plus root 3 times square root of 36 will give you 6. So let's come to the next step. So you multiply 3 and then 5. 3 times 5, get 15. Minus, we have 2 root 3 plus 6 root 3. So let's look at the expression. We have root 3 root 3. So we can comfortably subtract or add. That is like term. So all that you need to do, you add the numbers in front. You add or you subtract the numbers in front of the common set. So the common set is root 3. So 15 minus 2 plus 6. You put them in bracket. Root 3. Now, this is indirect way of factorizing. Yes, this is indirect way of factorizing, not just adding, because root 3 is common in all the terms. So you bring it out. When you bring it out, it will be left with 15 minus 2 plus 6. So take note. So 15 minus 2 plus 6, 15 minus 2 will give you 13. 13 plus 6 will give you 19. So you have 19 root 3. Yes, that is your final answer. Next on the screen, we have another question. Without using 4-figure tables or calculator, simplify. Root 50 minus 3 root 2 times into bracket 2 root 2 minus 5 bracket close minus 5 root 32. Well, as we did in the first question, we need to break the number under the square root into simple terms, into simple form. So next, root 50, we can break it into, we said that in breaking the numbers, always think about a perfect square. If you can get a perfect square. So we are fortunate, 50, we can easily get a perfect square, which is 25 times 2 will give you 50. Minus. Now we have 3 root 2 multiplying this whole bracket. It's the normal multiplication. But the difference is you make use of the properties of set. So if you have 3 root 2 multiplying 2 root 2, what you do is you multiply the numbers in front of the set first. So 3 times 2 give you 6. And then root 2 times root 2 will give you square root of 4, which will be 2, of course. Then let's come to 3 root 2 times minus 5. Here there is no set attached to the 5. So we multiply 3 by 5 and then maintain the root 2. So minus 3 root 2 times minus 5 will give you plus 15 root 2. Okay. Minus 5 times root 32, we can write it as 16 times 2. Okay. Let's go to the next step. We can split this one into individual. Let's split this as root 25 times root 2 minus 6 times 2. So root 4 will give you 2, which is a perfect square, plus 15 root 2. Once again, we can split this one, root 16. Let's split it first before we write times root 2. Root 25 will give you 5. So 5 times root 2 will be 5 root 2. Minus. This will give you minus 12 plus 15 root 2. And then root 16 will give you 4. So 4 times minus 5 will give you minus 20 root 2. Let's group all the terms containing the said root 2. Equal to, so 5 root 2 plus 15 root 2 minus 20 root 2 minus 12. 3 times we have a common set which is root 2. So all that you need to do is to add the numbers, add and subtract the numbers in front. So 5 plus 15 minus 20. 22 minus 12. So in the last, this is indirect factorization because root 2 is common. That's why the root 2 is outside the bracket. So 5 plus 15 is 20. 20 minus 20, you have the next step. You have equal to, you get root 2 minus 12. Then 20 minus 20 will give you 0. And 0 root 2 still 0. So you have minus 12. We're going to get minus 12. Yes. So that is the final answer. Next on the screen, we have another question. Simplify into bracket root 5 all raised to the power minus 2 times 75 raised to the power half times 12 raised to the power minus half. Now, care must be taken when you are answering such question. Remember, any number or any variable raised to the power 1 on 2 is the same as root of that number. So you're looking on the screen, root m raised to the power half, you can write it as square root of m. And then from indices, m raised to the power minus 1, you can rewrite it as 1 over m. With this idea, we can go back to our main question. So this is equal to, we can rewrite this one as 1 on into bracket root 5 all squared times square root of 75 times 1 on square root of 12. Okay, so this is equal to, we have root 5 all squared can give you 1 on 5, or the square will cancel the square root, times, for the root 75, we can break it as square root of 25 times 3 times 1 on root 12, we can write it as square root of 4 times 3. So next step equal to 1 on 5 times square root of 25. You're breaking the 75 times square root of 3 times 1 on square root of 4 times square root of 3. Okay, next step, 1 on 5 times square root of 25 will give you 5 times root 3 times 1 on 2 root 3. And let's look at the expression carefully. Root 3 can cancel with 3. And then 5 here can cancel this 5. Okay, so leaving 1 times 1 on 2. So equal to, this is equal to. So the final answer will be 1 on 2. Yes. That is the answer. Now, next on the screen, we have another question on set. Remember, we are solving questions on set. And most of them are past questions from Wassce. Now, let's look at the question. Simplify 2 plus root 3 all on root 3 minus root 2 minus 2 on root 2. But this particular question, there are 2 ways of doing it. One, you can find the LCM of the 2 fractions. With a set. Or you can rationalize each of the fractions separately. Let me take the second part. So let's rationalize 2 plus root 3 on root 3. This is equal to, now to rationalize, you multiply both the numerator and the denominator by the set of the denominator. So times root 3, this one over root 3, minus you can multiply both the numerator and the root 3 out times bracket open 2 plus root 3 over root 3 times root 3 will give you square root of 9, which is 3. Minus root 2 times root 2 minus 2 over 2 times root 2 will give you root 4, which is 2. Okay. So we can now find the LCM. This time, the LCM is not going to be in set. So LCM of 3 and 2 will be 6. Right. So LCM of 3 and 2 is 6. So let's draw a line. Yes. So 3 will go into 6 2 times. So 2 root 3 times 2 plus root 3. Close there. Minus 2 will go here 3 times. So 3 root 2 times root 2 minus 2. Okay. We then expand. So 2 times 2 will give you 4 root 3 plus 2 times 1 times 3 root 9, which is 3. Yes, 3. So that's 1. Root 3 root 2 times root 2. You have 3 times 2. Plus minus 3 root 2 times minus 2. So you have plus 6 root 2 over 6. So let's come to I 4 root 3 plus 6 minus 6 plus 6 root 2 4 over 6. So equal to 4 root 3 plus, but 6 minus 6 will go to 0. So it will be left with plus 6 root 2. So looking at this, see there is no common set. So you can't add the 2. Don't make a mistake of making sure that these are added. No. So you leave it as it is. But then you can go further, a little bit further. You can divide 4 root 3 on 6. 4 root 3 on 6 plus 6 root 2 on 6 on 6. So 2 root 3 on 3 plus 6 will cancel 6, making root 2. Yes, your equal sign. So questions on Z is not really difficult. You make sure you apply the properties and you will not have any serious problem. Viewers, this is how far we've come to. Just want to end today's lesson. Thank you very much for watching this video. Don't end it here, share with your friends. If you really want to get A1 in Wassce, this is your channel. I'm Samuel Watson with my colleague, Samuel Abebrese from USA. I'm from Pembekali. Yeah. So if you have any further questions or if you want further clarification, you can call this number 0242307846. You can WhatsApp me, and then we just want to make sure that you pass and pass well. God bless you. See you next time.